All right. Hello and welcome. Thank you very much for joining to our manufacturing wrap-up session. I would very much appreciate if you give us a like or a comment to confirm that you can hear us. And yeah, in this session, we are going to summarize and highlight the features and advantages of MicroStation, and at some point, other Bentley applications. That are valued the most by the users and by our guests. I have mentioned that there is a series. So to access the recordings on demand, you can go ahead and scan the QR code in top right corner to visit the registration page. However, for now, please stay with us. This QR code will not disappear through this session. And as this is the live session, I highly encourage you to actively participate. You can ask questions in the chat window or in the comments. Okay, so let's make a quick round of introduction. Our guests today are from the area of software application engineers and sales engineers. Joining me today are Dorota Mulinska. Hi, Dorota.
Hi, everyone.
Kamil Gasiński. Hello, Kamil.
Hello.
And Azar Wasim.
Hello, Bartek.
Hi, Azar. And Sam Bryant.
Hello, hello.
And yeah, I am Bartłomiej Zimmerman. I am sales engineer for MicroStation in EMEA region. All right, so let's start with a quick intro. As we have learned, delivering projects for industrial plants is a rather complex operation. You need to store a lot of project data, process it, respond to changes, and implement it efficiently. Our guests from various companies have shown us the many ways to efficiently deliver a project, manage it, and then pass the data on to customers for maintenance needs. Manufacturing has evolved over the centuries from human-based processes through heavy machines and electricity to another industrial revolution called Industry 4.0. But why are we highlighting the use of our technology when planning the manufacturing facilities? Manufacturing industry affects every aspect of our lives, from food over beverages, healthcare, clothing, furniture, up to cars and high-tech devices. And those factories have lots of common project requirements. We have a huge amount of information available to us now, and it is important to be able to work collaboratively, choose the right tools, and use them efficiently. The agenda for today's meeting is to summarize the topics covered in the webinar series. You can see now the main issues on the slide. And yeah, at this point, Sam, I would like to ask you to tell us more about one of our guests, which is Enrico Ferraro from Ferraro GmbH.
Yeah,
Passing to you, Sam.
thank you, Bartek. So in the second session of the manufacturing webinar series, we examined Ferraro GmbH, a CAD BIM company. Ferraro has over 25 years of experience stretching from 3D projects, laser scanning, and CAD modeling. They have over 10 years of active involvement in BIM maturity levels 2 and 3, giving them full integration within their project models. Ferraro GmbH has experience in all project phases in a wide variety of roles, stretching from owners to planners, contractors, and even into operations. Ferraro GmbH delivers sound and field-proven services within the industry.
All right, thank you very much. We also had another guest from Martin GmbH. Azar, you hosted this webinar. Could you tell us a little bit more about Christian and the project he delivers?
Sure. Thank you, Bartek. So, as Bartek was mentioning, that we are running the series on manufacturing industry because they're an important building block of our society. Because anything related to development or construction, manufacturing industry actually plays an important role. So, during the third session, we had one of our users from Munich, Germany, Martin GmbH. So they were presenting their project during the third session. It was really interesting to see our users like bringing out the success story and how efficiently they're using a solution. So Martin GmbH were involved in planning and construction of waste incineration plant, converting them to energy. So their expertise were like basically Christian was the CAD administrator and he was in this company for more than 27 years. So what we discussed was how these thermal treatment plants, because they're quite complex structure, they require a very high level of specialization in engineering and plant construction, I would say. So Christian actually showcases how our digital solution enabled their team to meet unique project challenges, included how they create drawings, 3D models of the plant components, display materials through geometry mapping, and much more. So, taking this opportunity, I would like to just quickly highlight some of the benefits that were highlighted during the session. So, one of them were parametric modeling, where they were talking about how they were used parametric modeling for steel profiles, designing the garbage chute. Material grading was something which they really helped them because in plant there are different materials being used like skid plates, steel. So how they were using different grating, material grating and using microstation. And they also discuss about the drawing conversion and data exchange. So because when you're working, you have a lot more companies involved in your ecosystem. You have contractors, subcontractors, so they might not be using the same solution. So data exchange always becomes a challenge in this position. So Martin has showed us how effective, like Christian was showing how Martin GmbH effectively used microstation for all the data exchange in terms of 2D, 3D, DWG, IFC. And whenever you're designing a manufacturing infrastructure, you need easy 2D drawing pullout from a 3D model. So in case if there's any changes that were made in a 3D model, how easily it could be reflected in the 2D drawing, how easy it was for them to extract 2D drawings from 3D model was something shown. And another factor which Christian showed was using Luminati and VR glasses, virtual reality glasses. So lot of people in the industry, they think because they don't adapt to technology that so easily. So what Christian showed us was how they pulled out the model, did the visualization using Luminati, and they use virtual reality glasses for the inspection. So places where physical inspection is not possible, there's not enough headroom in there, so they were using virtual reality glasses in order to inspect those areas. So which was quite interesting to see at that point of time, and we had a lot of interest from our audiences on that aspect. So I believe Kamil and Dorota can explain more in detail because they were part of the technical team who helped us present these aspects in more in detail. So thank you, and
All
back to
right.
Bartek.
Thank you very much, Azar. I really
Sorry.
appreciate it. Yes, indeed. Now we should dive deeper into technical aspects. And thank you, Azar, for introducing also Dorota and Camille. Camille, now I am turning the floor over to you, and I'm sharing your screen.
Okay, so I think it's visible now. So our first topic we discussed during the presentation with Martin was parametric modeling. And parametric modeling can be really useful if we need to create kind of our own databases, and we would like to use some geo would like to use some models that will be repeatedly used in our modeling. So in this example, we discuss about the steel profiles, and we try to use constraint tools to vary the different steel shapes over the model. So simply we start with defining 2D constraints. Constraints you can find under modeling tab, constraints, and you have different constraints for 2D elements and 3D elements. So once I created my profile is created by polyline. I define simply some geometrical properties between. It's very simple. So we just have to show to program which side is parallel, which is perpendicular to edge. Then we define some constraints like fixed point, and we can define our variables. So variables will be properties that we can assign to the distances between the elements, and by fulfill these constraints, we can modify our elements. So my local variables in this case for simple channel was height, width, thickness of the flange, and thickness of the web. and simply you can assign to element by defining the distance over the elements, and then from the available list you can pick up your variable or any other if you define, right? So this was the first topic, to define those variables, and first constraints to constrain our 2D shape, then assign to those constraints variables between we can change the dimension. And later on, after we create such profile, we extruded profile by 3D, and such solid now it can be modified by our variation. In this case, we create two variation, and simply we can apply to model. I think this one already was applied. So once we apply to model our set of variation, which we can predefine previous constraints, we can simply create our database of, in this case, UPE profile, right? So let me create as an example new profile which we call UPE 140. And in this set of properties, we will set up our dimensioning for profile. So height will be 140, width will be 65 millimeters, flange thickness 9 millimeters, and 5 millimeters web thickness. Right. Once we define such set of um, variables, we can apply to model and failed. Okay, let me check what is wrong now. 140. Okay, apply to model. Let me reset this element. Okay, let me double check if my constraints are fine. TW, B, TF, and height. Okay, so should be fine. If we go to variables dialog, okay, again, let's choose one of available, apply to model. So this one, it's working. Solid extrusion. I think I have some kind of error with this extrusion. But anyway, we can create our own database with different variables. So such variation, it will help us later on to distinguish the elements between each other, and we can create the whole database of steel profiles, for example. Second topic was about the material. Maybe coming back to the constraints, we can also define the different constraints over 3D model. So for example, if we have two 3D shapes, we can assign first the constraints, 3D constraints. It will look like that. First, we have to pick up the element, then pick up the edge. In this case, it will be whole plane. And then we have to pick up another element and another edge. It will ask to accept the constraint. Once we get the constraint, then we can define the distance between them, and sorry, by element. I will set up top view. Sorry, it should be 3D dimension between this element, this edge, this element, and this edge. So once we get this dimension, we can set up one of our variable. In this case, I predefine offset in X direction, and directly we get it. If we need to assign another one in vertical direction, we can use the same 3D dimension, just define the opposite dimension. So another plane with edge, and pick up another offset Y. Right? In this case, we can make the definition and simply modify our variables. So once I change it to half meter, our model will adjust. Right? So this distance will be shortened to half meter. So this was the aspect of 3D and 2D constraints and variables, and variation for defining our own database of set of variables. The second aspect was about the material and geometry map. So we try to get any 3D shape, and we would like to assign the material. And for cutting this element, we would like to get some geometry map as a, for example, hatching. So in this case, if I open my material editor, I can get my user material, which we defined that time, and you can find the steel. It was downloaded from internet, this pattern, this steel pattern. So it's maybe not the best quality, but just to show the example how we can make a differ material, and like expanding this kind of picture, we can get the difference in the presentation.
So you can
So
even draw your own pattern and use it as a user and use it here, right?
exactly, yeah, it's just a
Perfect.
picture assigned to the
Yeah.
material, right? You have much more option to define the material here, which will be reflected later on in the visualization, but I'm focusing only on this aspect. And
Mhm.
as an additional tool, you can set up your geometry map. And in this case, it's my hatching, it's straight lines. So once we create the 2D section, let me see if we have available from last session. Yeah, there is, but there is a problem with scaling. I need to change just the scale. But anyway, we can assign the material with different hatching properties to our material. Sorry, to our element. So coming back to the more, maybe I will just show one important issue from our presentation. Um because using 3D shapes, solids, it can be available also for other application like ProConcrete in this case. Because ProConcrete is taking all solids, you can also get the parametric rebar, and it will change if you modify your corbel. It's quite easy to achieve. So as I always say, if you learn MicroStation, you have open way to learn any other Bentley software, and you can utilize this knowledge even if you are doing some structural detailing with ProStructure. Um, Coming back to the main topics, we also discuss referencing capabilities. So in this case, I will use MicroStation as my repository for coordination. Um, so if we need to load some reality mesh, we can get it, and we can use for our coordination to just check the location of the structure, right? So MicroStation reading very well the reality data. Then if we have information from any other Bentley application, in this case, Open Building Designer, Plant, ProStructure, Substation, we can coordinate under MicroStation and just simply load the reference. In this case, I will add the architectural file. The structural, it already exists as a framing over the reality data. So I'm going to display. Now we have my structural file with architectural cladding data. Um, for example, if we add the plant data, so this is piping together with our warehouse, and to show the support, let's load the data from ProStructure. Right, all the files are geo-coordinated, so appear in the proper location. So we have to take care in separate file to be geo-coordinated. In this case, we have all our model data from different disciplines over one MicroStation file. And first we can do the visual coordination, right? So under 3D environment, we can review the model. We can go to the details without modifying yet the file. So for project coordinator, it's great tool to just see that, for example, something doesn't match, right, between piping and structural. We can see if there is no visual collision, like collision that you don't need any tool to catch it, right? We can find that there are some clashes with pipes. So this is just great tool to coordinate everything under one design file. Also, if you need to model some temporary site building, like in this case, it's MicroStation. Actually, it's building MicroStation as a container, like site administration building. We can apply, we can check and coordinate with other models. So this is quite easy to achieve. We are using only referencing capabilities, and to show you the available file, we have large of available formats. So starting with MicroStation with DGNs, which include most of Bentley portfolio, but also AutoCAD, DWG, DWX, some 3forma elements, 3D Studio, and many more SketchUp files as well. So you can easily import the data for visual coordination. And I think the last topic I would like to mention, it's about the clash detection. So it's also coordination tools. Uh, so clash detection tool, you can.
Mm. Camille, may I
Mhm.
interrupt you at the moment?
Yep.
There was a question from the audience.
Okay.
Is it possible to make adjust? It relates to your previous topic.
Mhm.
Is it possible to make adjustments to the patterns? As I understand, it's I don't know, to fit
I
the scale of the pattern to the
Yeah,
to
of
the object.
course. Yes, it's possible. You can adjust the scale and modify. So it's matter of units only.
All right,
Also,
all
I,
right.
I would like to ask that if you already create your pattern, you can select the element, and then in the properties there is the property pattern origin, and you can manually change the origin point from which the pattern will be then spreaded.
Mhm.
Mhm. Okay, I don't see any other comments under the comments tab. So I start talking about the clash detection tool, and clash detection, you can get it. You have to first define your job description, right? So in this case, we can, for example, define str plus piping, and then you have to define the level or references between which you would like to um, compare your model, right? So for example, we will take the pro structure, which is our main structural file, and it will be our set A with red color, and we would like to get the plant design from open plant, and it will be set B with blue color. Once we process, we will get the set of clashes between those two references. So you can create a very global check like now between the references, but also you can define local between levels, right? So we can go less um, to the lower level of detailing. I will just maybe turn off this mesh, reality mesh, just to see the clash detection between elements. Of course, it's not the perfect tool, but we can catch some major clashes, right? We will get the report. Then we have also some status that we can change, right? If we know if it's old, if it's accepted, if it's new or follow up, so we can somehow manage some of those comments. Of course, the export it's not the perfect one, but for very simple inside Office, we can create very nice clash detection report under one file, which is not require external tools for it, right? So we can check one by one and go through the clashes. So not only visual one, we have also dedicated tool to go through clash detection. I think that's all. That was the main topic of the presentation with Martin.
All right. Thank you very much, Camille. Just to make it clear, it is possible you now you have attached the part of this model from other Bentley applications. So it is possible to the geometry must not necessarily be designed in MicroStation to use this function to detect the clashes, right?
Yeah.
And to put them into the
So
reports.
yes, the most important that you can take the data from other application and start modeling using your MicroStation. So you are using the whole context of other designs, and you are just inbuilt your design in the proper place, coordinated already. So it's very good solution for existing project that you have like reality mesh from existing data, or you have models from any other discipline. So it's quite easy to achieve, right? So
All
now we
right.
have our full MicroStation with ready context of the existing structure.
All right. So this is the function of MicroStation, right?
Yeah, that's
All
right.
right.
Actually,
All right.
all the Bentley building tools like Open Building Designer, ProStructure, OpenPlant, including this clash detection tool.
All right. So you don't have to buy another application to have these possibilities.
Yes. Mm-hmm.
Perfect. Perfect. All right. Thank you very much, Camille.
Mm-hmm.
So now I turn over to Dorota to cover the topics of animations, item types, drawings, and batch process. Dorota, I will share your screen now.
Sure.
Here we go.
Okay, it's visible. Okay, so first we will talk about item types. And item types are non-graphical information which you can create and then add to any geometry in MicroStation. To do that, we can go to item type manager. And in my case, I always use that search ribbon, which is available from Connect Edition. Here we have item types manager. First of all, you need to create a library. Library can be a local one, or you can have separate DGN lib file, which will contain all your libraries. So for example, I can call it structural. And when the library is ready, we have to create the item type. In this case, I will call it a column. And then we have the next button to create new property definition. In this case, for example, I will create the first one, which will be the height. And then on the right, you can see some properties related to that property. First thing which we should start with is the type of this property. And as you can see, you have a couple of types here. It can be a text, it can be a number, integer, true, false, date, or point. So for example, in case of height, we can select the number. We can also put the default value, which can be later changed. And also we can put the assign the units here. I can also use the working units, so depends on the new units I'm working with, the value will have the same units here. Okay, then let's say I will create another property. It can be, for example, the construction date. And then, sorry. Okay, and then in this case, we can, for example, use the date time. You have a default value, you can set the proper date, and that's it. Then we can also, the next icon here is the new property type. And property type is a collection of properties which can be used by any item type in the same library. So if I create a property type under my structural library, this property type will be available for all my item types here. So let's say I will create a new property type. I can call it column geometry. And then we can also add some properties like height, length, and width. And now when the property type is created, it will be displayed under the type here. So here, before we have only the text, number, integer, and so on, and now we can see also our property type which we created. So as I said, it can be used later in couple of in any item types you have. So let's say I will create here a new a new type. Sorry, column-metry. I will change the name here. It will be only geometry. So in this case, I could use this geometry also for beam, for example. So let me create a new item type, which I can call beam. You can also just, copy and paste existing item type, rename it. Delete that one, and then I will rename it. So then, as I mentioned, then the geometry type will be available here under the type. So we can just place it here, and then both those item types will contain all those three properties. Okay, so it's a quicker way to assign the same properties to several item types. Okay, then you can do that either under property type or in each properties under item type. But as you can see, despite of those property definition, you have also calculated property and pick list options. So you can use either calculated pick list, calculated property, or pick list. Okay, you can't use both. So in this case, we can go to expression, and here we can use some expressions. There are separate trainings for that. If you want to know how to use them, just let me just type in the proper name here. Sorry. So we can start with this. That element get display value. And we will force the software to, in this case, we force our software to read the value from element. So if any geometry like solid or something like that have the height property, it will read this value and display it in our properties. So we can test our expression. I can put OK, and then this will be the calculated property. Let me now close that item type manager. I will save that and I will create the geometry. Wait a minute. Okay. So now we have the empty geometry without any non-graphical information. Yeah, but as the geometry was made and software knows that there are some values like height, length, and so on in this situation, then we can force our software to read those values. So as you can see here, we have a height. Of course, we can change those values, and then software will read those values. So to do that, first I will attach the item type. Okay. So I can use my BIM item type, and you can see now in the properties, the item types is assigned, and under our properties, we can find our item type properties which we created. So we have a height, we have construction date, which of course can be changed. Then we have our property types, height, length, and width. Yeah. So the same like here in the height, which uses the expression, ready expression, we can do the same with those three values, and they will be read by the software. Yeah. So in case I change the geometry, you can notice that the value here will change. And we can do the same with the surface area, the height, length, and so on. Then let me come back to item types. And as I mentioned before, we have also the pick list option. Okay, so once again, I will create a property. And let's say I will call it construction. Okay. So of course we could manually create text for that and so on. But so you could just type in the value like new, existing, or temporary geometry and so on. But you can also use ready pick list to do that. So let me open the pick list manager. I've already created here the pick list. So first you need to create a new pick list. Yeah. Then on the right, you can put some values. So I have a new, existing to renovate, existing to demolish, temporary construction. And then we can use that that list, that pick list. So in this case, I will just go to that pick list option here, pick list source, and you can have two sources, DGN file, so as I just did, so I created my pick list inside my file, inside the DGN file. It can be also DGN library, or you can use the Excel file. In our case, I will select DGN file, and then if I open the settings option here, I will see all my pick lists, either from the working file or any other library from this workset and workspace. So let me select this one. And now you can notice that if I close this, let me once again create the geometry like that. Okay, I will attach item. Sorry, not here. Okay, and now if I go to my properties, you can see that column item type is assigned, and now all my column properties are here, and also we have the construction phase. And now we can just pick the construction phase from the list. So those are pick lists. Then another topic which we were talking about during our third webinar, was the Explorer, which is really nice tool, and it is connected with item types as well. So let me let me delete those geometries here. I will reference in ready model. Okay, and now if I open my Explorer, you can do that from the home primary tools. Under the items part, you can see all item types which are already used in this model. So those item types are already assigned to a geometry here. And it is a really nice place to find your elements, to isolate them, and so on. So let's say I will select my columns. You can see some elements are highlighted in my model. Those are elements which contain that information about item types column. Additionally, we have here some tools like transparent, so you can make everything transparent instead of your geometry. You can zoom in to everything, or you can isolate. It's really dark here. Okay. And the same, you can use the search ribbon to find some elements here and to force your software to find those elements in the model. Sorry, it freezed. Let me close that. Okay, so The next topic will be the visualization part, and I would like to focus on the animation part. Okay, so we will create a short animation. So I will show you how we can quickly create an animation, which then you can use to show your client the building, the project, and so on. So if we have our model, first of all, we need to go to the visualization workflow, where you can find the Animate tab with all your tools here. So that what I mostly do is to go to the top view, especially in case of this kind of model. Then I can create the B-spline curve. And we have to create a path. So I'm using that tool to create kind of the path, which will go through the building. Then I will move it a little bit up. Okay, so let's say it will be our path. Then the next step is to create camera or the actor. Okay, so you can treat your camera as an actor also. So I would like to create the camera. This will be the beginning, and then we can put the name, camera 1. Okay. Then we can select define actor path tool. Then with the tool setting dialog, you can point the actor, okay? And then you can select the path for the actor and the direction. Here you have a time, so I will say that timing is okay here, the start and the end point. And then we need to use the script actor tool. Once again, I will select the camera one. We have some additional settings here, but let's say we'll stay with the settings we have here. And then we can use the animate preview tool to see our, sorry. Camera 1. Okay. Okay, and we can play the animation. Yeah, so the actor is moving, our camera is moving along the line we pointed. Okay, so you can see it's quite fast and simple. Then we can use that option here to stop in one moment. Let's say I will stop my camera now, and you have also additional tool which is called target. So we can create a point which will be the target of our camera. So I use the create target option. Then I can point to the point here, target 1. And then we can use the script target option. And in this tool setting dialog, you have that start time. It will be taken from the animator preview. So as I moved my video, it read that value here. Of course, you can change it. And then we can select the object, which in our case is the camera, and our target will be target 1. From this point, from the 39 seconds, it will start looking at this target. So I can accept it, and then let me to play our animation once again. Sorry.
Dorota, may I interrupt you at this point?
Yes, sure.
MicroStation is known and recognized as a powerful CAD tool, 3D CAD tool, not necessarily an visualization or animation tool. Is there any learning path or I don't know, some kind of courses available for users to? This
Yes,
process
sure.
looks simple, but maybe some users will need to have some
Yeah.
support.
So of course you can find some additional learning paths on our Learn server, or some posts and blogs in Bentley communities, but also there are a lot of learning path on YouTube channel. And let me just paste the basic path of animation and new PBR materials and so on. I will paste it into the chat.
Oh, perfect.
So I do recommend to. Oh, okay, Bartek, I paste it in the private chat because I can't do that in the comments. Can you pass that
Of
to
course, no worries. I
YouTube?
will post it in the public comments area, so everybody have access to this.
Yeah, sure. So coming back here, so let's see. I will play my animation once again. And what has changed is that from the 39th second, camera is looking at the target. Then it's going to the other part of the station. It's still looking on that target. So it's a really nice option also to focus on some details in your model. Of course, then you can record that video, save it as you can save it as a video, then move AV, for example, and then you can use it in any situation. Okay, so that's all about animation. And now I would like to focus on some tools related to drawing creation, which is the biggest part of your work probably. So in MicroStation, we have some ready tools to create drawings. So if you go to Annotate tab under Drawing Workflow, you will find some detailing tools. We have here the Plan callout tool, Section callout, Detail, Elevation callout, and so on. So let me go to the front view, and then I will use the Plan tool. We need to select the drawing sheet, which is a template for your drawing. Okay, so it will contain all information about drawing scale, the display styles, which are used for all for the cutting plane, for elements which are in the forward view, in the back view, and so on. It is only a template, so you can change it later if you want. Okay, so drawing sheets can be prepared, and I do recommend to prepare them for your company as well. So if we select the drawing sheet, we can select the create drawing option directly. And then I need to select 2 points, and then the third click is the depth of our drawing. Okay, so I can click here, and the create drawing option dialog will show up. Let me just close it for a second, and I will create a new, once again, the plan, because I want to show you that you can also create the stepped plan. So if you use the control button and start clicking, you are able to create the stepped plan or the section. Okay, so let me, before I click OK, you can see here, those settings here are taken from the drawing sheet. So the scale, if the drawing is cached or dynamic, the sheet, the naming, and so on. You can also change that. But if you mostly create your drawings in 1:100 scale, it is worth to create your drawings in this case. So I will change the scale and I will click OK here. As I selected both drawing model and sheet model, these will create both the sheet and the drawing will be placed in the drawing. Okay, so if I go to my model tab, you can see we have two new sheets, two new models, drawing model and sheet model. And not only MicroStation build its drawings upon the concept of models, but also upon the concept of references. So if I go to references tab, you can notice that when I'm in the sheet model, inside reference, there is the reference to the same file, but to another model, to our drawing model, okay? Then, so I could just turn it on and off. Then if I go to the drawing model, you will notice that inside the reference tab, I have the reference to 3D metric design, but with the clipped volume used. So as well, it is only the reference. That's why both model, 3D model and drawing are connected with each other. Also, when we create our drawings, we have so-called markers. They differ with the icon, depending on that if it's a sectional or plan or elevation, detail, and so on. But also, mostly all of them will be white, and only one will be yellow. The yellow one shows you indicate that it is the drawing or model which is now used by you. Okay, so I can hover over it and then I can select if I want to go to the drawing model or sheet model, and I can open the target. Also, of course, I could move to another drawing, not only that active one. I could, for example, let's say I would like to open the section which is somewhere here, and it's easier for me to get to that point from this location. Okay, so I can also just select the drawing and open the target. Also, from our markers, we not only can open drawing model or drawing sheet model, but we can also go to our design model, to our 3D or 2D model. And if I click on that, my drawing, my design model will be open. It seems like it is the 2D model, but let's say I start to rotate my model, and you can see that it is the 3D model with a clip volume which creates that drawing. Okay. Then we can also from this point we can also go to the drawing or to the sheet model. Let me just clear the clip volume, and I will come back to my drawing model. And then if I come back to the reference dialog, I can go to set reference presentation to change the visibility of my drawing. As you can see that reference presentation seems to be really similar to view attributes, but you can find here additional settings, which are clip volume settings, and those settings correspond to that how our model looks. Yeah, so you can turn on and off back or forward view, and then you can cut view and outside view as well, and then you can decide which display style is set to this clip volume part. Okay, so we can, for example, turn on the back view, save the changes. I need to refresh my drawing because it was cached, and that's it. Okay, and in this case, you can notice here that the back view is now visible here. Okay, I'm afraid it took me too long, so we haven't got much time. Or can I?
No worries, no worries, Dorota.
Can I
You have
continue?
shown a lot of details. I think we have one topic left,
Yes.
which is
So
batch
can I
process.
continue? Yeah.
Yes, of course.
Sure.
Maybe put it in few sentences and yeah, of course. Let's
Sure.
continue.
Sure.
Let's continue this.
Okay. So let me just change one setting here. So I will change my view to dynamic, and I will move to the batch process tool. So if we go to backstage view tools, here we have some additional nice tools like batch converter, batch process. We have also under print, we have a print organizer. All those three tools are tools which allow you to make some changes in couple of files in the same time. So you can print, in case of print organizer, you can print a couple of files, couple of sheets from other files as well. In batch converter, we can change the extension of our files. So you can decide that you want other DGN files, DGN models to be converted to DWG, for example. And what is the most interesting for me is a batch process tool, which allow you to use some ready instruction, let's say, which will go through pointed files and do those steps one by one without your help. Okay, so in this case, first of all, we have to add some files here. Okay, so let's say I will just add the file which we are in, but you can even select a couple of files. Okay, and then we can either open already existing file or create a new one. And those file seems to be simple text files. Okay, I will open it for editing, and you can see that inside this file we have just the, as I said, the instruction, what to do. So we are using the key-ins. Okay, so those are the shortcuts for some tools in MicroStation, and this is the key-in which will refresh the model and change it from dynamic to cached. Okay, so I will save this file, and now we can just process that. So let me process that file. Sorry. Not sure if it's okay. Oh, sorry, not here. Sorry, it didn't read the file here, but let me check once again. Okay. And I will process it. So the tool will open each model or each file and each model, depending that what we used, and it will refresh it from dynamic to cached. Okay. So if we have work like that we have to open each file and do that manually, it is much more faster to create a file like this with the instruction, and then you can just process it and leave your computer for a couple of minutes or whole night, let's say, and then it will do it by its own. So I can click done, and I will not save it, and you can see that my model now is cached instead of dynamic. Okay, so this is, and you can do everything with that, even change the level names in each file, let's say, everything, to be honest. Change the working units also. So this is really nice tool. Okay, so that's it. Sorry to be not quick.
All right. Thank you very much. Thank you very much, Dorota. You've shown your these aspects in really in details. Really appreciate this. All right. So let's move back to the presentation, and there was a few questions which are already answered in the comments. If you want to ask about anything else, just feel free to reach out to us in the comments field or directly on LinkedIn. All right, so in the webinar sessions we also had another two guests. In the first session, it was a kind of roundtable. So let's quickly review the first webinar. It was a roundtable, as I mentioned. We had guests from two companies, our channel partner from Germany, Venturis IT, who delivers a wide range of Bentley applications and services like trainings and consulting services. And also they are delivering their own application, TriCAD MS. And this TriCAD MS is a great support for MicroStation users. It delivers a complex solution that allows you to design piping and steel construction for plants as well as P&ID schematics. It is also a great for building design, offering 3D models for heating, ventilation, sanitary, sprinklers, electric, and schematics HVAC. We are also hosting Martin Siegel from Stadler Engineering. He has shown us the benefits of using both MicroStation and TriCAD MS, using all features that Dorota and Kamil has just shown us. Martin has showed it on the example of a real project. In this case, the plant facility. There was a building designed in 3D environment in MicroStation with support of TriCAD MS for HVAC and sanitary design. Highly encourage you to review this this first webinar, this roundtable. All right, so thank you all very much for being with us. Thank you for questions, thank you for your attention. This concludes this webinar series. However, remember that all recordings will be available for you. Just scan the QR code, which is still visible. We are planning to do more. The upcoming webinar series will concern transportation, mining, and utilities. We'll have excellent guests. Even if you are not from this industry, it will be worth to attending. So yeah, stay with us. This is it for today. Thank you very much. And thank you guys for joining.
Thank you.
Thank you all.
Bye.
Thank you. Have a good afternoon. Bye.
Bye.
Bye.